Alright, how's it going? So I'm gonna work through every single one of these problems, and you can if you can watch this whole thing, or you can fast forward to the ones that you're struggling with. I'll try to pause at the beginning of every problem so you can fast forward and find the ones that you're looking for. Okay, but this is important. Every single one of these problems will have one very similar to it on the test. Okay. So number one, triangle DEF is a right triangle and E is the right angle. Okay, we've talked about this before, but it doesn't matter. Okay, it doesn't matter what this triangle looks like, except for the fact in this case it's a right triangle. DEF. The measure of angle D is 5x plus 2. That's this angle right here. And the measure of angle F is 7x plus 28. Find the measure of each angle of the triangle. Alright, well, what do all the angles in a triangle add up to equal? 180 degrees. Okay, so when I'm just going to add all three of these angles and set it equal to 180. Alright, so 5x plus 2 plus 7x plus 28 plus, do not forget the 90, equals 180. I'll move that over. So I'm going to combine my like terms. 5 plus 7 is 12. 2 plus 28 plus 90 is 120. And then from here it's just solving for x. That's 60. 12x equals 60. So when I divide by 12, x equals 5. Now I'm not done because it wants every single angle here. So it wants the measure of each angle. This is just the value of x within these angles. So to find angle D, it's 5 times 5 plus 2. Move that over. We know angle E is 90 degrees. We were told that. And angle F is 7 times 5 plus 28. Well, 5 times 5 is 25, plus 2 is 27. 7 times 5 is 35. 35 plus 28 is 7 times 5 plus 28, 63. And here is our answers. 27, 90, 63. Okay, next one. So this is 2, 3, and 4. Now, we want to find the missing sides. So notice we're giving an angle and we're given a side. Well, this is where we're going to use trig. Okay, remember? This little phrase helps me know when I'm going to use sine, when I'm going to use cosine, and when am I going to use tangent. If I'm given like the opposite and the hypotenuse, I'm going to use sine. If I'm given the adjacent side and the hypotenuse, I'm going to use cosine. And if I'm given the opposite side and the adjacent side, I'm using tangent. So looking at this one here, from this angle, I'm going to go through my options. From this angle, I have the opposite side and the hypotenuse. That is sine of that angle equals opposite over hypotenuse. The opposite side from that angle over the hypotenuse. And we've talked about this before. This is one where to get x by itself, I multiply 10 sine of 47. Now, make sure, okay, can't say this enough, that you hit mode and make sure your calculator's in degrees. And then 10 sine 47. So that angle, or that side, is 7.31 or 7.3. 7.3. Okay, number 3. I go through my options. I check opposite over hypotenuse. That doesn't work. I check adjacent over hypotenuse. That does. So cosine 47 equals adjacent over hypotenuse. Adjacent side over the hypotenuse. So in my calculator, it's going to be 12 cosine 47. 12 cosine 47. I get 8.2 as my answer. Okay, moving on. Number 4. I'm going to check tangent. Well, this one is tangent because sine doesn't work. Opposite over hypotenuse. Cosine doesn't work. Adjacent over hypotenuse. Tangent. Opposite over adjacent. So tangent of 34 equals 15 over x. Notice this one's different because if I move up, notice x was on top here. Now x is on bottom. So this is one where in the calculator it's 15 divided by tangent of 34. If I put that in the calculator, 15 divided by tangent of 34 degrees, 22.2 is my answer. Okay, 5, 6, and 7. Okay, if I'm given 3 sides, we're going to call C our longest side. Okay, so remember this was in your notes. A squared plus B squared equals C squared. That tells me it's a right triangle. If A squared plus B squared is greater than C squared, it's acute. If A squared plus B squared is less than C squared, it's obtuse. I'll move this over. Okay, A squared plus B squared, A and B meaning the smaller sides, C being the largest side. So I'm going to check this. Okay, I'm going to check 12 squared plus 16 squared, and I want to compare that to 20 squared. 12 squared plus 16 squared. I compare that to 20 squared. They equal each other. So because they equal each other, this is a right triangle. Okay, let's check this one. 10 is my largest side, 4 squared plus 8 squared. And I compare that to 10 squared. Notice, A squared plus B squared is less than C squared. So 4 squared plus 8 squared, comparing that to C squared, that's less than. So when it's at less than, this is obtuse. And finally, for the sake of time, 8 squared plus 15 squared, comparing that to 17 squared, they're equal. So that's a right triangle. Okay, next one. Find the missing side lengths. Now, you're going to have on the test, you're going to have answer choices like this where they have a square root. Now, unless I've taught you special right triangles, which I haven't taught all of you, and that's fine, you're going to have to be able to convert this. But you have a calculator, so it's not that big of a deal. So I'm going to use trig to find this missing side. So if I'm looking for x over here, I'm going to use 45 degrees, and I'm going to use 7 square root of 2. Don't worry about, I know it looks weird, just don't worry about it, okay? It's just a number. So I'm going to check opposite over hypotenuse. That works. So sine of 45 equals opposite over hypotenuse. Well, what I type in the calculator is 7 square root of 2 is equal to sine of 45. Okay, so that's what I type in. 7 square root of 2 is equal to the sine of 45 degrees. So 7 is that length. Well, because here's kind of a trick in some ways. Because this is 45 degrees and that's 90, 90 plus 45 is 135. 180 minus 135 is 45. Well, if this is 45 and that's 45, that means their opposite sides are equal as well. Okay? This one. Again, I'm going to use trig to find these missing sides. So let's try to find B right here. Okay? This is the side I'm going to try to find first. So I'm going to use this angle 60. Maybe this helps. Okay? Maybe rotating it. So I'm going to use tangent. Opposite over adjacent. Don't be freaked out that there's a fraction there. Equals opposite, that's a B, not a 6, over adjacent. Well, to find B, what I'm going to type into my calculator is 5/2 times tangent of 60. Again, it's just a fraction. Don't let that freak you out. 5/2 tangent of 60. And I get 4.33. Now, if I look, none of these values of B have 4.33. So what I have to do is I have to check which ones would equal that. I know it's not this one, because 10 is just 10. So I know it's not that one. So let me check 5/2. Well, 5 divided by 2 is 2.5. That doesn't work. So let me check 5. Let me see if 5 square root of 3. I'm going to put that in parentheses. Divided by 2 ends up equaling 4.33. Yes, it does. Okay, this is just another form of the way to write that. Okay, so use your answer choices to double check yours. All right. Again, if you wanted to know how to find A, real quickly, A is going to be, I'm going to use cosine of 60 equals adjacent over hypotenuse. And so it would be 5/2 divided by cosine of 60, which is 5. Okay, real quickly, moving on. 10 and 11. Notice 10 and 11 are using the same problem, so I'm going to draw that image right here. So we have a plane. I'm not going to try to draw a plane because I'm an awful artist. But we have a plane, and let's say this is our ground, and this is the plane going up. Okay? So it's rising at a constant 36-degree angle until it reaches an altitude of 3 miles. Okay, this altitude, that's the vertical height from the ground. That's what altitude means. So it wants to know what is the plane's horizontal distance from the airport. Well, obviously it's going to take off from the airport, and it wants to know this horizontal distance. Well, this is just using tangent. Tangent of 36 is equal to opposite over adjacent. When x is on bottom, I divide. 3 divided by tangent of 36 degrees, we get 4.12. That is that horizontal distance. Okay, let's look at this one. Same problem, but now what is the plane's total distance traveled in the air? Well, on this case, you could use Pythagorean theorem, but I'm just going to use trig. Because now what I'm looking for is this distance right here. When he's 3 miles above the ground, how far has he traveled in the air? That's what it's asking. So this one, to find that length right there, this is going to be sine. Sine of 36 degrees equals opposite over, let's call it y. Hypotenuse. Opposite over hypotenuse. So in the calculator, it's 3 sine of 36. So 3 divided by sine of 36, 5.1. Okay, just a word problem using trig like we've been doing this entire unit. Alright, this one, notice, we're looking for missing sides. Well, I'm given 2 sides, so if it's a right triangle and I'm given 2 sides, I can use Pythagorean theorem. So this is x squared plus 10.8 squared equals c squared. Notice, okay, we're given the hypotenuse. The hypotenuse is always opposite the right angle. So that's my c squared right there. I'm going to highlight that so you can see where I put those numbers. I'm looking for one of the legs. That's why it needs to be set up like this. So if I'm using my calculator, 10.8 squared is 116.64. 13.8 squared is 190.44. So x squared plus 116.64 equals 190.44. Well, to get x by itself, I just need to subtract those two. And then take the square root. Don't forget to take the square root. Again, so here's our answer, 8.6. Again, make sure your answer makes sense in the context of the problem. If you stopped at 73.8, that doesn't make sense with these numbers. Okay? This makes sense. This one here, we're actually solving for the hypotenuse. So 8.4 squared plus 14.6 squared equals c squared. This is one where we just add them and take the square root of it. And for the sake of time, let's see, we're doing number 13. We get 16.8. Add those two, then take the square root. Okay. Moving on, almost there. Matthew normally drives 5 blocks north to work, and then 12 blocks east to get to work. Okay, how many fewer blocks? This is key. You need to read these questions carefully. How many fewer blocks would Matthew have to drive from his house to work if he was able to drive directly diagonally between the two distances? Well, let's find what that would be. Let's figure out if there was a direct distance, what would that distance be? So 5 squared plus 12 squared equals, let's call it c squared. 5 squared plus 12 squared, I'd take the square root of that. So this distance is 13. Okay, but here's the thing. It didn't ask what that distance was. It wants to know how many fewer blocks would that distance be. So I need to add these two, because what he normally does is he drives 5 blocks, then 12 blocks. Well, 5 plus 12 is 17. So he normally drives 17 blocks. So if he was able to drive a direct distance, it'd be 13, so that's 4 fewer blocks. Okay? Pay attention to that. Okay, so find the measure of the angle. Remember, when we're looking for an angle, you're using your inverse functions. So it's still using the acronym SOHCAHTOA. to figure out, am I using sine, am I using cosine, am I using tangent? So on this one, I'm going to use tangent. Tangent of that unknown angle is equal to opposite over adjacent. So what I type into the calculator is tan inverse of 32 over 39. Okay, so when we're typing that in, you hit second tangent, the ratio you're using. So second tangent, sorry I had video problems for just a second. So second tangent 32 divided by 39. So that angle is 39.36, so we'll just call it 39 degrees. 16. Am I going to use sine? Am I going to use cosine? Or am I going to use tangent? I'm going to use cosine because from this angle it's the adjacent side over the hypotenuse. So cosine of that unknown angle is 24 over 25. So in the calculator, cosine inverse 24 over 25. So second cosine 24 divided by 25 is 16 degrees. Remember, when you're looking for an angle, you're using these inverse functions right there. Here's a real world problem of using the inverse problems. So we have a guy wire. We've talked about these before. So here's our telephone pole. It's a terrible drawing, I know. Is attached. So here's our wire right there. And it's attached to the pole at a height of 40 feet. And it's attached to the ground 20 feet from the base of the telephone pole. So mine's not drawn to scale, obviously, but it wants to know what is the angle of elevation created by the ground and the wire. So we want this angle right here. Well, this would be tangent inverse of 40 over 20. So second tangent, 40 divided by 20 is 63 degrees. Equilateral triangles. All 60-degree angles. All sides are the same length. Alright, so we have an equilateral triangle here, and it wants the altitude length. Well, its sides are 15. 15, 15, and 15. Well, if I zoom in right here, I'm going to highlight it so it's easier to see. This right here, that's a right triangle. And I want to know this height. Well, can I use sine of 60? Sine of 60 is equal to opposite over hypotenuse. Right? From this angle, opposite over hypotenuse. So 15 sine of 60 is what I'm going to type in the calculator. 15 sine of 60. Move down. 12.99, which rounds up to be 13 inches. Okay. Isosceles triangle means two equal sides. So we have an isosceles triangle, and the base is 12, and the vertex angle is 68, and it wants to know the altitude here. Again, mine's not drawn toward in scale because this is going to cut this in half. Okay, the base, this vertical line will cut the base in half, and it's going to create a right angle. So it wants to know what is this side here. Well, what this is also doing, I'm going to redraw half of that, okay? Because this vertical line is also cutting the vertex in half. So this is 34 because 68 divided by 2 is 34. This is 6, and we want to know this side. So maybe that helps you visualize it a little bit easier where our trig ratio is going to come from. So it's going to be tangent, because tangent of 34 is equal to 6 over x. So in the calculator, it's 6 divided by tangent of 34. And let's see what we get. Zoom out for you. 8.89, so we'll just say 8.9. Almost there, last one. Okay. So we have a building, and we have a 12-foot ladder. So this is 12 feet. The ladder itself is 12 feet. And again, I haven't really drawn my picture very well, but this is 4 feet because it's 4 feet from the base of the building. So it wants to know, what is this height here? This is a Pythagorean theorem problem, okay? Right? Because I want to know this, I have two sides. So 4 squared plus x squared equals 12 squared. 16 plus x squared equals 144. I'm going to subtract 16. X squared equals 128. When I take the square root of 128, I get 11.3. Okay. So here's a review of all the answers. Okay, I'm going to go ahead and give this to you. I might have given it to you, but here's a review of all 20 of those answers. Now, after watching this video, if you still have questions, then just come ask me, okay? Or go back to those numbers and re-watch the video. Maybe hearing it a second time will help you, okay? But here's all of those answers. You can pause it while you mark these down and while you double check. All right, well, but I appreciate you watching this and taking the time to do so.